Going to wait to see if it's streaming. I think I'm gonna stay here for 1 hour today. I'm almost finishing the last video that I have to do, which I'm gonna put together. I was gonna do 2 separate videos, one for async await and another for promises, but I decided that it doesn't make a lot of sense. It's better to do them together. Yeah, but I didn't want to stream today, but just for consistency, I decided to do it. So that's why I'm gonna spend only 1 hour here, because I wanna finish this video. I talked about the syntax and then set interval. And now the next one, I think the final one, I'm not sure. I did one time, but I didn't like it that much the way that it was. So I have to talk about this callback hell here, and I also have to clarify, because I'm not 100% sure. I understand how it works, but I want to make sure that I'm saying the correct things to not mislead people. So I was spending a bunch of time studying this stuff. As far as I understand now, the way that it works is under the hood, async IO is just an event loop, and then you have something that is called microtasks. And the way that it works is it puts the code on a loop until the callback, until whatever you're waiting for gets done, and then it executes the callback. So I imagine that on the source code of the promises, you have an if-else statement or something like that inside of the set interval. And then once the if statement gets passed, let's say, once you receive the data or whatever you're doing, then the code inside of the if statement is going to execute, which is going to execute whatever you want to happen after the promise is done. And that's how because the promise is an object in JavaScript, and that's what is used to handle async await. And under the hood is just these event loops. But I want to clarify a little bit more how the microtasks work. But I'm not sure. I'm probably not going to talk about it in the video. It's just for my own sake, because I think that's enough to understand. So the issue with using multiple set intervals is that it gets confusing because there's multiple different callbacks, and then you don't know when each callback is going to finish, so it's really hard to debug. So people built the class or the object called promise, and the promise has these attributes here, which is pending, fulfilled, or rejected. And then based on whatever happens, you get the response, and then the response goes inside of this then statement here. So inside of the then statement, you have a function. The argument of the function is going to be the response, and then you do whatever you want with the response, which is usually going to involve parsing that into a JSON. Then something that was a little bit confusing is sometimes you can chain that then method twice. After you put on the catch here to catch errors, you put another then, because only that way you receive the data. But I guess that depends on the API you're calling. That's the thing. But it's not really clear to me which one you receive. So I don't understand how the promise works really well under the hood, the source code. And also how the microtasks work in the compiler or interpreter of each what is going to be the order that it gets executed. But like I said, I think I'm just going to film this stuff, and I'm not going to go too deep into this, because I just explained the surface. Otherwise, it's just going to take too much time when I start building the blog. Hopefully I can finish this video today. I have another one that I filmed today, so I have to edit that one as well. But ideally, I would be able to get done with this today so I can start the blog tomorrow. And I think I'm gonna try to post in intervals of 2 days, the videos that I have left now. So I'm probably gonna have anywhere between 8 and 10 days to build the blog, I think. And then until I have to start thinking about what other videos I'm gonna make. And I also think I'm gonna make one video which is gonna be all the other videos that I've done so far, and I'm gonna put all them together in one. So maybe that's gonna buy some time as well. And then after I build the blog, or as I do build the blog, I'm gonna start looking for jobs, for freelancing jobs, and for blockchain jobs as well. And then also, I think the blog is gonna be very difficult because I'm thinking about the idea that I have so far is to do 4 main sections. One is gonna be programming, the other is gonna be neuroscience or health and fitness. I think I'm gonna put health and fitness. It's gonna work like a tree structure in the way that I'm envisioning in my mind. I'm gonna put 3 or 4 main topics in the first page. Then depending on which one of these topics they click, there are gonna be other topics on top of that, because that way I can have enough flexibility because I don't know which direction I'm gonna go. So later on I can remove or add topics, and the only thing that is gonna change is the layers that they have. And then each one of those topics, there's gonna be articles about it. I'm gonna write articles about it. So the main ones are gonna be programming, economics, and health and fitness, and blockchain, I think. And then out of these, I'm gonna put the JavaScript, Python, then the frameworks. And then in health and fitness, I'm gonna have brain anatomy, I think. Neurochemistry, obviously. And then I wanna study these hormones. And the last time I went to the nutritionist, I wrote down a bunch of stuff that she told me. And I have it here. And I think what I'm gonna do is use ChatGPT to write articles about this kind of stuff. Well, first, obviously, the goal is to focus on programming. So I think I'm gonna start by writing articles about programming, the stuff that I've done so far, and also the blockchain. I want to study because that way it also increases the chances of getting a job, I think, or getting freelance work. Because the more I study about this stuff, the better I become, and it kills 2 birds with 1 stone. So I think I'm gonna start with blockchain stuff probably, and I already have a lot of ideas actually of things that I can write about that I think is interesting, like zero knowledge proofs, optimistic rollups, different consensus protocols, and MEV, the arbitrage bot stuff. That's gonna be interesting and also really hard to do, I think. So I'm not gonna spend too much time studying this stuff here. I just wanna get done with these videos. But initially, it's not what I wanted to do. I wanted to dive deeper, but it is not realistic, I think. It's not a good strategy. Maybe in the future, I make more videos about this and then I'm able to go deeper. Put some music. Actually, I'm gonna watch the videos first. Yeah, these are videos that I've watched already a long time ago, and I'm just reminding because I remember there was one video on Node.js in particular that I thought was really good, and I think is this one, but I don't remember really well. Yeah, but besides this, I don't think there's much to talk about. I'm just thinking about which order I'm gonna. First, the video that I done so far, which is the way that I've been doing this when I'm not satisfied with the first take, I do multiple versions and then I just put the name of the file in v1 or v2, v3, like that. So I did the v1 version and I started off by talking about this, which I think is the way that it works, but I'm not 100% sure, which is what you actually have under the hood is a nested structure of set intervals when you have multiple promises that you want to make. So multiple API calls nested together. And then the issue that people faced with this is that you don't know when you're going to receive the callbacks. So it becomes a mess to debug because it's very hard to understand what is going on. And then that's the reason why people made promises. But the question that I have is, what's the difference with the promise and the set intervals? Is it just for debugging purposes or developing purposes in the way that you write? Or is there a difference in the source code? and I couldn't find any videos. I found one video, but I just didn't pay too much attention because I'm kind of tired today as well.
Welcome back. Let's now learn all about the event loop, which is the heart of the Node.js architecture. And this is probably the most important lecture in this section, so make sure you really understand everything that I show you during this video. So let's get started. So here's a diagram similar to the last lecture, so that we know exactly what we're talking about here. So we're still in the node process in a single thread where the event loop runs, all right? Now, the first thing that you need to know is that the event loop is where all the application code that is inside callback functions is executed. So basically all code that is not top-level code will run in the event loop. Some parts might get offloaded to the thread pool, as we saw in the last lecture, but it's the event loop that takes care of all this. As I said before, it really is the heart of the node architecture. Okay, now as I mentioned many times in the first part of the course, Node.js is all built around callback functions. So functions that are called as soon as some work is finished, sometime in the future. Remember that? And it works this way because Node uses an event-driven architecture, which is something that we're going to talk about in one of the next videos. But what you need to know for now is that things like our application receiving an HTTP request on our server, or a timer expiring, or a file finishing to read, all these will emit events as soon as they're done with their work. And our event loop will then pick up these events and call the callback functions that are associated with each event. Okay, makes sense? So again, the event loop receives events each time something important happens, and will then call the necessary callbacks such as we define in our code. So in summary, it's usually said that the event loop does the orchestration, which simply means that it receives events, calls their callback functions, and offloads the more expensive tasks to the thread pool. Now, how does all this actually work behind the scene? In what order are the callbacks executed? Well, that is what we're going to find out next. So remember, when you start our node application, the event loop starts running right away. Now, the event loop has multiple phases. Each phase has a callback queue, which are the callbacks coming from the events that the event loop receives, just as we talked about in the last slide. Now,
Oh, there's a really good video as well. It explains event loops.
Around to the render steps.
But it's still hard to understand. Because I think he doesn't go, maybe he does and I didn't understand. He doesn't talk about microtasks. But this is really good. So I'm gonna put this link on the description of my video as well.
Places you will read that there's only one callback queue or one event being processed, well, then callback of that timer will only be called as soon as the event loop comes back to this first phase. Make sense? It works like this in all four phases. So callbacks in each queue are processed one by one until there are no ones left in the queue, and only then the event loop will enter the next phase. Next up, we have IO calling and execution of IO callbacks. And again, remember that IO stands for input output. So calling basically means looking for new IO events that are ready to be processed and putting them into the callback queue. And remember that in the context of a node application, IO means mainly stuff like networking and file access. And so it's in this phase where probably 99% of our code gets executed, simply because in a typical node app, the bulk of what we need to do is related to networking and also file accessing, some more than use cases. Four phases in the event loop, but besides these four callback queues in these two special queues, they will execute right away. And the same logic also applies to the next queue. Both are for really advanced use cases and we're loop. So now it's time to decide whether the loop should continue and go straight to the next tick. So for example, when we're listening for incoming HTTP requests, like we did in our node farm project in the previous section, we're basically running an IO task. And that is why the event loop and therefore Node.js keep running and keep listening for new HTTP requests coming in instead of just accessing the application. Also, when in Node.js, making it the most important feature in Node's design and building heavier tasks into the thread blocking or single thread, which was expensive. On the other hand, there is no danger of functions in the FS, crypto, or the synchronous version there. Finally, don't use all too complex high-level guidelines, but for now, it's important small example to show you some of the stuff that we talked about in practice.
Hello, and welcome to Section 4, Asynchronous Programming. In this section, we will learn asynchronous programming, which is a very important programming technique in JavaScript and Node.js. We will look at why Node can achieve a very high I/O performance through the event loop. Then, we will tap into callback functions and the error first pattern. Finally, we will learn the basics of async.js and promises. Now we move on to the first video of this section that deals with the event loop. In this video, we're going to take a look at the single-threaded concurrency model of Node.js, which is based on non-blocking I/O operations. We will also learn how to set delays in Node, key presses, and incoming requests. Blocking I/O, or all know that Node is a very high-performance server. The event loop. If a request doesn't involve a blocking I/O operation, Node will simply process and prepare the response and send it back to the client. In another case, if a request requires blocking I/O operation, Node will delegate it to an operation. The blocking I/O complete, the worker thread will prepare the response back to the client. The single thread event loop runs. Go to the terminal, create an init. We say create a new file, console.log, the first statement. In the program, it's to be delayed, and the second parameter is let's apply to the second. Run the code again. So we added a delay, or not, without waiting. And then after 2 seconds, how long the delay should be. Means that we can't control the program.
So he's talking about that when you use this set timeout or set interval, it creates a queue. JavaScript queues the thing as an event, and that's the reason why it doesn't run right away. So everything in the code executes before the set timeout, and then only after all the code executes, then the set timeout callback executes. So even though the time could be 0 there, it's only gonna execute after the rest of the code.
I'm back again to here on my channel, and I'm super. So this code will be quickly executed to execute this console log JavaScript after 5 seconds. Now to execute this callback function after 5 seconds. So now how the website works. So the callback function, a function, right? And we add this. Isn't it powerful? So now let's make things a little more complicated. So we created an order. Now after order is created, we proceed to payment. Now this callback function to proceed to payment API. Now it is the responsibility of proceed to payment API to complete the payment and call this function back. That's how we can manage this dependency between this whole flow, which happens one after the other. But do you see a problem over here? Let me show you a very important problem that we can face, right? Oh my god, I'm really just fast from here. But yes, let's continue with the code. Hope it doesn't come back. So now we have created the order, we have done the payment, we have shown the order summary. After that, suppose we also want to update the wallet. How would we do that? So now we again have an API, right? We again have an API to update wallet, right? So that happens, the wallet will be updated only after we have shown the order summary. So how would you write that code? Again, we will have a callback function over here, and when we pass this callback function, you would have already got bored seeing me doing this again and again. We will pass this inside show order summary. Okay? So do you now see a problem with this code? Yes. So when we have a large code base and there are so many APIs here and there, and APIs are dependent on one after the other. So what happens is we end up falling.
Let's see if mine is correct. I got this from ChatGPT. I just changed the set interval. It used another stuff. Yeah, but I think this is correct.
Do this callback hell. What is a callback hell? So one pyramid of doom. Okay, you can Google it. So it is because of this structure, it is known as pyramid of doom in programming. So now we saw the first problem, but now I need your utmost attention because now we are going to discuss the most important part of this episode. That is the inversion of control. And trust me, this is really, very important to understand promises as we go ahead. Okay, so please pay attention. Please give me just 2 more minutes and I will teach you this. Okay, so let's study inversion of control. Inversion of control is another problem we see while using callbacks. And Alice explains it very beautifully in you don't know JS. So inversion of control is like that you lose the control of your code when we are using callbacks. Now it might sound a little complicated. How do we lose control of our code? But let me show you with a code example. We will use the same example which is here. Okay, so let me just get rid of this callback function first of all. So now what is happening in this code is we are creating an order. And now listen to me very carefully. What we did here was we take this callback function and we give it to create order API. And now we as a developer are sitting back, relaxed, and we are blindly trusting create order API. How we are blindly trusting? We gave this callback function to create order API. Now we are expecting that create order function at some point of time will create an order and call our function back. Isn't it risky? This is very risky, very risky. How it is risky? Because this is an important piece of our code, isn't it? Proceed to payment. What we did is we gave the control of our program to create order API. Now it is the responsibility of create order API to call our function back. And we are blindly trusting create order API. Now we don't know create order API must have been in some other service or some other developer wrote it or an intern wrote it, right? There could be a lot of bugs inside create order API, isn't it? What if our callback function was never called? Can happen, right? You don't know what is the code in create order API. You're just blindly trusting it. What if our callback function is called twice? Proceed to payment happens twice because we don't know what is happening in the create order API. So what I'm trying to explain is that whenever we have this callback function and we pass it to some other function, we are giving the control of our function, right? Our piece of written code to some other code, and we don't know what's happening behind the scenes now, right? So this is a very important problem that we face when we are using callbacks. And we as a developer don't realize this, right? I have written so much code and I have seen so much code and have seen this happening so many times. But this is a very important and a risky thing which we need to take care of. So as we move ahead in the next episode, we will see that how this inversion of control can be handled in our code. Okay. So for now, just keep these 2 problems in your mind, and that's all in this episode. Before we end this episode, let us quickly recap what we studied. So first of all, we studied that code, and in the next episode, like explaining you just the gist of it.
Okay, then so far we're just calling get-to-dos once, and that is making this request once to get the to-dos.json, then logging the data to the console. But what if we have several files that we need to get one after the other? So for example, we have a to-dos folder here, and we have 3 lots of to-dos, one's for Luigi, one's for Mario, and one's for Sean. So we have those 3 JSON files, and what if we want to go out and get each one in turn? And by in turn, I mean we want to request the first one, and we want to wait until we get the data back to that first one, so we can output over here in the browser before we start to go and get the second one. So once we've got the first one, then we can start to make requests for the second one, and we can output those to the browser, and then when that's done, we can go out and make requests for the third one. So this idea of waiting until one request is done to go out and do another request is quite common when you're making requests to different APIs. Often you might need to make requests to one API to get some data, and then use that data to make requests to another API, so we have to do them in turn. So how would we do this? When would we make a request for the second one? And how do we know that the first one is done so that we can make requests for that second one? Well, we know right here when the callback function fires, at this point we know we have the data on error, but generally speaking we know we have the data at this point. So this would be a good time to then go out and do our second request because we know the first one's complete. So what I'll do first of all is I'm going to delete this right here. This is the endpoint of the URL that we're trying to get data from. Now, if I call this function 3 times, it's just going to get this data 3 times, which we don't have anymore. What we want to do is replace it with these 3 files. So I can't hard code this because then it's going to go and get the same one every time. Instead, what I'm going to do is pass another parameter called resource into the get-to-dos function. Then I'm going to output that resource here as a second argument in open. So what we need to do is pass through a resource, which is the URL to whatever we want to get into get-to-dos whenever we call it. So we'll do that. So the first one we're going to get is Luigi.json. So I'm going to pass that in as our first argument. We need to go into the to-dos folder first of all, then Luigi.json. So that is our first argument, which is resource here, and that will be output right here. So we'll make a request to get this thing right here. Now, when it's done, it's going to do all of this. For now, I'm going to delete that check-in. So this should be all of Luigi's data. Let's say that test it. It's all of Luigi's to-dos. So now we have those. We're going to output the second one, which is down here, and under the console log, let's now say get-to-dos. So to-dos /console.log the data. Luigi one first. Then when it's done, we go out and get Mario. Get-to-dos again. We'll just console.log, save it, and check this out. And we get 3 sets now. We get Luigi. Then this is fine. It's working. And we're back in callback. It doesn't.
What exactly is callback hell? Hi, my name is Eric Norman, and these are my thoughts on functional programming. So, a lot of it's common in the JavaScript world to talk about callback hell, and sort of casually people will talk about how when you have all these callbacks, you have to start indenting and indenting and indenting, and it becomes hard to keep track of where you're at. You're going further and further to the right in your editor, and your lines are getting long. And if you've got line length limit, you now have to make your lines shorter and shorter. All of those are kind of a pain. But when people refer to that as callback hell, they're actually missing the point. Because one of the things that has been proposed as a solution to callback hell is promises. And the promises, it basically lets you chain, instead of nest, it lets you chain. And when you chain, you can just go straight down at the same indentation level. And that is nice because you don't have this major problem of ever-increasing indentation. However, it doesn't solve the deeper hell of callbacks. It's the same hell. The deeper hell of callbacks is that you have totally given up control of when your callback is going to be called. Every
Yeah,
time you
that's
call
what I
something
was
as a
thinking. Because it doesn't make sense. So this is the part that was weird to me, that they said, because the way that I saw in the videos, they explain like this, where you have this callback hell, and then in order to solve that, you use the promises. But I don't see how it changes anything, because you're still doing under the hood. The only thing that changes is make it easier to understand what's going on when you're typing the code. But under the hood is still the same problem, I think, because there's nothing fundamentally that you can do about one call depending on the other one.
callback that could be called anytime later. It's like you're creating a different timeline. It's like you're creating different threads. No, JavaScript doesn't have threads, and that was probably a good choice. In fact, JavaScript has a pretty cool concurrency model, meaning it uses this, meaning if you have the thread, it's yours, and you can just run with it as much as you want. But as soon as you call something that is asynchronous, you give up that control. And that works great for a lot of things because you know that while I'm modifying this variable, nothing else is going to happen.
Let's watch this one.
In the callback hell lecture, we learned that a callback hell has a
I
lot
think I'm
of
not gonna watch these videos because they're not gonna have. I'm just gonna watch the beginning, but they're probably not gonna answer the question. I think I'm gonna try to use ChatGPT to clarify this, and then search on Google or DuckDuckGo with ChatGPT to try to get and understand. But there was a good video, maybe I'll go back and watch it, that the guy is explaining how the promise is constructed, but I didn't pay too much attention. I think the problem is that he started off from a point that he already had some code. So I didn't follow too much.
Advantages. And we should always avoid callback else in our JavaScript program. And there, I have mentioned that we can avoid callback else by using promises. And that's exactly what we are going to learn in this lecture. So in the last lecture, we made an AJAX request using Fetch API to get information related to different countries like USA, Germany, and Brazil. Now currently, if I refresh the page, you will notice that the sequence in which these countries are appearing might change. And the sequence in which they will appear is not in our hand, because the data which will be returned first, that will be displayed first in the web page. So if the information related to Brazil comes first using this Fetch API, in that case, the information related to Brazil will be displayed first in the web page. So the sequence in which these countries are appearing is not in our hand. But our requirement is to display these three countries in order of their population. So for example, United States has the highest population, so we want to display it first. Then Brazil has the second highest population, so we want to display it second. And then Germany has the least highest population, so we want to display it third. Okay, but currently if I refresh the page, the order, as you can see, might change. Okay. Now the same thing we tried to achieve in the callback hell lecture, where we wrote hard-coded to USA. Because first, the promise returned by this Fetch API is then methods, right? Now, once we have the data related to United States, Fetch API pass that data to Germany. Callback. So displayed in the web page. And
Yeah, same
that's why we
shit.
can call one then method. If I want to display data related to Brazil also, then I will make
I think I'm gonna look on the history for the other one that I watched.
What's up,
Wow,
everybody?
isn't
This
sure.
is John
These other ones.
from Coding Addict, and welcome to another JavaScript Nuggets video. And in today's video, I want to continue with our callback function topic, and more specifically, show you what is a callback hell. So if you have been following along with the series, you know that in the last video we covered callback functions, and even though callback functions are great and very widely used, there are some situations where promises and async await make our code easier to manage. Don't worry, I'm planning to start tackling promises in the next series video. But before we do that, let's struggle a bit and see what callback hell is all about. Lastly, even though in my example I use below for the time, that is my variable, then blue, and then
Yeah, I
So
think
as
there's
this
nothing
changes-
new here, probably. So I'm gonna watch this again. I'm gonna finish this one and then watch the other one.
the thread, and I'm going to define. And they'll read it. When they're reading it, nothing else has the thread, so they know nobody's modifying. That is really nice. The problem is, as soon as you need to do something with a callback, you actually introduce a new timeline. The current thread is going to keep going, and then this callback is going to happen at a different time, sometime later, but you can't say when. And then that callback might have a nested callback in it, and that callback might have a nested callback. And all of those are going to happen in order. So they're in a thread, they're like in the same timeline in order. But now if you have multiple of those going on at the same time, and very likely you do if you're in a JavaScript environment where a button click is a callback and an AJAX request has a callback, and maybe you have 4 AJAX requests going at the same time, like you're going to have all these timelines.
It's analogous to the data race problem, I think, where you have multiple threads trying to access the same data. They're sharing memory and trying to access the same data. And then there's a problem when both of them want the data at the same time, or because they're not running synchronously. And then I was reading something about this in the book. I have to keep reading this book, but about operating systems that it talks about this stuff. And then you can use some techniques, I think it's mutex or lock, something like that, where you put some if-else statements on the code, and then you find some logic there to synchronize or to make it so that if a thread wants to access the shared space when another thread is already using, then it gets blocked because the flag variable is set to 0 or something like that. And that's the solution they found for operational systems, I think.
All of those could interleave.
There's several different solutions, obviously, and I have to read more to understand. But superficially, I think that's what's happening.
So the actions in each of those timelines could interleave. So now you don't have the possibility of that, I got the thread, I'm going to hold on to it. You still have that while you've got the thread, but anytime you go, so you still have this like, okay, I'm going to read this value. I'm going to read a value from a variable. Let's say it's a global variable. I'm going to read a value. I'm going to make an AJAX request to the server based on that value. The server's going to give me an answer, and I'm going to write that into the variable. However, in the meantime, since I've done that request, while the request was in flight, another thread read that variable, made a decision, and wrote back to it. Right? This is entirely possible, and it's the exact same concurrency problem that we had before we had threads. Even though JavaScript has one thread, we still have this multiple timeline sharing problem, sharing a common resource. And so that's one aspect of callback hell, is that it reintroduces threading. The other one is if you have to do multiple AJAX requests and then reassemble the answer into something coherent, the best thing to do in a callback world is do them one at a time. However, that's not the most efficient. You need to do all 3, just send them all out at the same time. Let the server handle all 3 and respond. The problem is they each have their own independent callback. Now, promises can help with this very simplistic scenario where you want to get all. So there's like a promise.all method, and so it'll just wait for all of them to come through. And then there's another thing called promise.race, which is where you have 2 callbacks. Let's do the simple case. You have 2 callbacks.
I've seen this from ChatGPT as well, but I didn't know about this.
And you want the first one that comes back. Right? So you do a promise.race on the 2 of them, and it will return a new promise that is the first one that comes back. However, what about that second callback? What if you want both? You just want them in the order that they come back in. but in the same thread. You've seriously limited what you can do. And so there's all these little scenarios where you've got like promises within promises where you're still in hell. It just pushes the hell off a little bit longer. So that's callback hell. My name is Eric Normand. You can reach me on Twitter at Eric Normand. I'm also available over email, eric@liftcast.com. Please subscribe to this, however you subscribe, whether that's on YouTube or on a podcast catcher. And
Yeah, this is the video that I watched, but yeah, the issue here is that he has multiple tasks and he already has some stuff here. And on this code, he also uses promises, so I didn't understand really well, like, how it works here.
In JavaScript. On the right, I've got my promise class, which at the moment is just an empty class. And on the left, I'm importing my promise class. And then I have a test suite that I prepared for this video. And I'm just going to start from the top and make this test pass one by one. Let's look at the first test. It says execute function is called immediately. Execute function refers to the function that is passed into the promise constructor. To make this test pass, we can just simply call the execute function. It's the only argument passed into the constructor. Let's look at the next test. It says resolution handler is called when promise is resolved. So resolution handler refers to the function that is passed into then. And what this test is asserting is that when the promise is resolved with a value, then the resolution handler should be called afterwards with that same value. If we run the test, we'll see that we get an error. Promise.then is not a function. Okay, so let's first create a function called then. Next, we get an error saying resolve is not a function. So we need to pass a function to this execute function. So I'm going to use underscores here to denote private methods. So I just create a method called resolve, and then I pass it into the executor. Now, it's important to remember to bind it to this, because otherwise we can't use this inside the resolve method. Of course, this won't still work. We still have to implement these functions. Let's first understand which order these lines of code are executed. So first we create our new promise, so we call it constructor. Then we call promise.then and pass in this function. And then 100 milliseconds later, so we're using set timeout, the promise is resolved. So because we first call then and then resolve the promise, that means inside this promise object, we have to store a reference to this resolution handler. The resolution handler is passed into then, and now we have to take that and store it somewhere. Now, in the interest of time, I'm going to anticipate some of the future tests here. I know already that it's possible to attach many resolution handlers to a single promise. So I'm going to create an array called resolution queue, and that's where we're going to put our resolution handler. Now that we have a reference to our function, we need to call it inside resolve. So here we iterate over the array. We always take the first one off the array, the first function, and then we call that function, and we call it with the value that is passed into resolve. Let's move on to the next test. So this one says promise supports many resolution handlers. Now, as I said, I would anticipate a little bit. So because we use this array and we push this resolution handler to it, and then in resolve, we go through the whole array and just shift off.
I'm not sure if I think I'm gonna put this link here as well, because that way I can put the references on my video.
All the functions and call them. This test should pass already. There we go. Let's move on to the next one. It says resolution handlers can be chained. So in this test, we call then, but inside then, in this handler, we return a new promise, and we call then. Let's see what happens if we just run the tests. So we get cannot read property then of undefined. But the first one we have to do is return a new promise in then. So let's think about this a little bit. We have to capture this promise, and when that promise is resolved, we have to resolve the promise that we return from then. And that's going to trigger this resolution handler that we attach to the return promise. So how do we capture this? Well, that's the return value of the resolution handler. We call it here, so we can just assign the return value to a variable. We check if the return value is an instance of my promise, and then if it is, we'll call then, and here we should resolve the promise that we return from then. So we need to store a reference to this promise. Because the resolution handler and the new promise are inherently associated with each other, I'm going to create a new object that stores
Yeah,
a
this
reference.
is the stuff that I don't understand in this video, is how he's using then here. I don't understand what he's trying to do. From what I think he's trying to do, he's trying to create the promise class from scratch to show how it works under the hood. But then the issue is that he's using the then method here. And that's the thing that I don't understand, because the then method is supposed to be from the promise. So unless it's this then here that is calling, this is the thing that is confusing to me, because I think the flow is first he binds the this here in the executor, so you're able to use it inside of the resolve, I think. And then inside of this then method, he passes whatever function, callback function you have into this queue here. But here, yeah, he's creating another class here with the function. And this binds this function to this, to another instance of the class. Then he's pushing the handler, pushing an object with handler equal to resolution handler, which is the callback function, and the promise is new promise, which is another instance of the class. And then from this it goes directly here, I think, where it resolves the handlers here, or calls the callback functions that are inside of the queue. So it removes and then calls the function with the value that is passed here. It's kind of confusing. Maybe we should see if he has other videos before this one. Yeah, but I know that this is a good video. It's just I'm having trouble understanding it.
To both of them, and then push that object to my resolution queue. Because items in the resolution queue are objects now, we have to change this to refer to the function by saying resolution.handler. And here we can resolve the associated promise. Let's move on to the next test. It says chaining works with non-promise return values. So what we're testing here is that if we return something that is not a promise, then the next promise will be resolved immediately with that value. Now at the moment, if we return something that is not a promise, we're not even resolving the associated promise. So this function is never called. We need another condition here. Another test works, but I noticed that we should add a test here to make sure that the return value exists. Let's look at the next test. It says resolution handlers can be attached when promise is resolved. If the promise is resolved already, it should still be possible to call then with a new handler. That handler will simply be invoked immediately with the stored value of the promise. So here we call promise.then and give it a handler, and inside the handler we wait for 100 milliseconds and then attach a new handler to that same promise. If I run the test, we'll see that this fails. This inner function is never going to be called. So we'll need to add a check to then. So if state is resolved, we have to do something special. In the constructor, I give the state the initial value of pending. And if the state is resolved, we actually just want to process this resolution handler and the promise which is created and pushed into the resolution queue. And we can maybe just call this .resolve, but the problem is we don't have this value that is normally passed into resolve. So the first thing we have to do is we have to store that value. So assign the value to this
I think what I'm gonna do in my video is just briefly explain and then explain that or talk about this video and then tell people to go to this video to understand more. That's probably the best thing, best compromise.
Value. And I changed the code below.
The only thing that I want to understand still is the microtasks, but I guess this video explains probably. I'm just not understanding.
To this underscore value instead of just value. And now I can extract this part to its own method. I'll call this new method both in the resolve method and in then. The test still fails because I forgot to change the value to resolve in this resolve function. So let's do that. Okay, let's move on to the next test. Calling resolve second time has no effect. So in this case, this call to resolve should have no effect whatsoever. The test fails because every time we call resolve, we set this underscore value to the new value passed into resolve. So let's fix this. We only do anything if the state is pending, otherwise we'll just skip the whole method. Next, rejection handler is called when promise is rejected. Rejection handler refers to the function that is passed into promise.catch. And what we're testing here is that if we reject the promise, then the rejection handler should be called. If we run the test, the first error we get is promise.catch is not a function. Okay, so we need a catch method. And I already know that the next error is going to be reject is not a function, so we need a reject method as well. And we need to pass the reject method into the executor. Okay, now we get this test exited without ending that we've seen a few times before. And that just tells us that the handler is never called and t.end is never called either. So we want to do basically the same thing that we do in resolve, but in this instance we want to save the handlers into another array. So I'm going to call that array rejection queue. Okay, our reject method is almost the same as resolve method. The difference is that instead of this underscore value, we're going to store the argument into a variable called rejection reason. And the state that we're going to transition into is called rejection. And then instead of running the resolution handlers, we'll run the rejection handlers. And I need to implement a method called run rejection handlers next. Run rejection handlers is almost the same as run resolution handlers. The difference is this time instead of iterating through a resolution queue, we iterate through the rejection queue. And instead of calling the handler with the value, we call it with the rejection reason. Next, we have to implement catch. Again, catch is almost the same as its counterpart. Then the difference is that instead of storing the handlers to the resolution queue, we push them to the rejection queue. And instead of checking if the state is resolved, we check if the state is rejected. And then we run the rejection handlers. And that takes care of that test. Let's move on to the next one. So this test says chaining works with rejection handlers, but I think actually a better description would be rejections are passed downstream. What we're testing here is if I reject the original promise, then we'll skip all the following resolution handlers and go directly into this rejection handler that we're attaching here right at the bottom of this chain. Now this doesn't work yet because the only thing we do when the promise is rejected is we run the rejection handlers. So in the reject method, in addition to running all the rejection handlers associated with this promise, we should also go through the resolution queue and reject all the promises that we return from the then method. This way the errors will bubble up to the bottom of the chain, and this function should be invoked as well. Okay, all the tests passed so far, so let's go to the next test. So what this test is called rejecting promises returned from resolution handlers are called properly. So what this is testing is that if we return a promise from a resolution handler, and if that promise rejects, then the rejection handler attached to that returned promise should be invoked. So let's go here. So this is where we resolve the promise if the returned promise is resolved. Now to do the same, but for rejections, we can simply call catch here. And inside catch, we just reject the promise returned from then. And that works. Next, rejection handlers catch synchronous errors in resolution handlers. What we're testing here is if I throw an error in a resolution handler, that should be treated as a rejection, and basically this rejection handler down below should be invoked with the error. If we run the test, we notice that the error is thrown, but it's never caught. So where can we catch that error? Well, we can catch it here, where we call the handler in the first place. We'll wrap it in a try block, and then we simply catch the error. And then we simply reject the associated promise with the error. And now our test passes. Let's move on to the next one. It says rejection handlers catch synchronous errors in the executor function. So we're basically testing the same thing, but for the executor function instead. What we'll have to do is wrap the executor invocation in a try block, catch the error, and then reject the promise with the error. Now this doesn't work yet, and the reason is that we throw an error before we even attach any handlers to the promise. And inside then, we don't handle the case where the promise is already rejected, so we'll have to add that in. So we just reject the new promise with the rejection reason. It says rejection handlers catch synchronous errors. So this is the same that we did previously for the then method. So if the rejection handler throws an error, that should be treated as a rejection as well. So what we'll have to do here is we have to wrap the call to the rejection handler in a try block and then catch the error and reject the next promise with that error. Okay, let's move on to the next test. So this is just testing that if we return a new promise from a rejection handler, it should function just the same as when we call then. So there's really nothing new here, and it works right out of the box because of the way that we implement catch. It's basically the same thing as then, but we run the rejection handlers instead of running the resolution handlers. And then we return a new promise, and the way we treat the promise is identical with catch and then. Move on to the next test. It says rejection promises returned from rejection handlers are called properly. So in this case, we test that if the promise returned from a rejection handler is rejected, then that rejection should be called in the following rejection handlers. Now this doesn't work yet because we have to add a couple of lines of code. Now earlier we added these lines of code to run resolution handlers method, and we have to do the same thing up here as well. Just change this to rejection. Let's move on to the next test. It says second argument in then is treated as a rejection handler. So as you may know, then takes two arguments. First is a resolution handler, and then also takes a rejection handler, and we haven't implemented that yet. So let's do that now. The only thing we have to do here is just push that rejection handler into the rejection queue. Whoops, and we get a bunch of errors, and that's because we'll first have to check if this rejection handler actually is a function at all. Okay, then on to our last test. The description is second argument in then is attached to the promise then is called on. So I think it's a common pitfall with people who are new to promises. When we pass this rejection handler into then, that's not the same as just chaining it with catch, because this rejection handler is going to be attached to the original promise, whereas the rejection handler that we pass into catch is going to be attached to the promise that is returned from this then method. And here we see why that's important. If we return a promise that rejects, then it's not going to be called here. This function is never run. Instead, it's going to be called here down below. So this is why I don't really ever use this feature, the second argument to then. I just always add a catch method at the bottom of the chain. And we don't really have to do anything to make this test pass. I just wanted to add it there because this is a point of confusion for many people. So it's just something that is good to keep in mind when you're programming with promises. Okay, that's it for this video. We have a reasonable promise implementation. It's not a perfect implementation. There are some edge cases that we don't handle, and it's probably not the most performant, fastest promise implementation out there. This is purely for educational purposes. The goal for this video was to demystify promises a little bit and just take away some of that magic. And hopefully you learned something. Leave a comment if you have any questions, and see you in the next video. Thank you for watching.
Greetings friends, welcome to a shot of code. Today we're going to talk about macro and micro tasks. Now a micro task is one that will complete straight away after your code block completes. So these are asynchronous tasks basically, and how and when they're handled. So when your code completes, a micro task will complete without the browser getting a chance to jump in and do any of the things that it would like to do, like refresh the page. Whereas a macro task, that will allow the browser to complete all of the tasks that it's got queued up before executing your task. Look at that, let's have a quick look just so you get a feel for it. Okay, the first thing I'll do is create a macro task. Now, an example of that is the set timeout. So if we just create a quick function in here, main afterwards, so I just timeout, these tasks are taking no time to complete, but they are being queued ready for the browser to run them when it feels ready to do so. Okay, so let's then do promise task and get that to complete. Well, get that to log out when it completes so we can see. So we'll call that task 2. Like so. Clear that down. Right, I just enter it here, we should get a clean run. There's one more in there, so we'll just do that. So what have we got this time? Again, the whole block completes, so we get main code completed. Then our asynchronous code gets a chance to run. And what we're seeing is task 2, even though it was added and run after task 1, is actually completing before task 1. And the reason for that is that it is a micro task. And this micro task queue will run before any macro tasks and before the browser can jump in and do anything. Okay, so that is the difference between micro and macro. It's not something you're going to use as such, but it's very useful to have in the back of your head and to understand how that works. It links into the whole how the event loop works and the browser and pulling off the tasks. I'll put a link into a very good video by Jake Archibald on the event loop if you want to look more into this sort of thing. But it can help when you're, say, trying to split up long-running tasks. If you want to be able to split them up with a timeout, then display the progress of that task. Then with a timeout, it's a macro one. And so each time you queue a new one, you're going to get a refresh and see it. But if you've done it with micro tasks, then yeah, you can split your long-running operation up, but you're not going to get the output shown on the screen because it will never refresh the new videos as well. Thanks very much.
Hey guys, I'm Nishan, and welcome to Cybernetico. So in this video, let's learn about microtasks versus macrotasks in JavaScript. So what are these tasks here that we're talking about? Micro versus macro. So everything in JavaScript can be categorized as a task. For example, let's say console.log, this is a task, this is a task 1. Let's add a function, task 2, and in here we'll print console.log, task 2. Now we'll get task 1, but we have to move the function to get task 2, like this. We'll get task 1 and task 2. Similarly, we can have some more like this. Let's have a promise. Let p equals to new promise. Let's resolve it. It will take 2 params for resolve and reject. We don't need reject, we only need resolve right now, so we can say resolve it. Simple. Then we can say p.then to successfully invoke the promise. So we can say console.log task 3. So we get task 1, task 2, and task 3. Similarly, we have one more task called set timeout. Let's say this. You know how it works. It will take the code inside its body that it wants to run. Let's say console.log task 4 and one interval. So let's say 0. So these are all tasks in JavaScript. All these are tasks. So what happens in JavaScript is, let's say this. This will move inside the call stack. Then it will be popped out after execution. Then this will move in. Then this will move out. Then others as well. So this was how call stack works. You can watch any video on call stack if you want to learn it in depth. Now let's see the difference between micro versus macro tasks. Micro versus macro. We have two words, micro and macro. So to demonstrate this, let's add some code. So console log, just console, not log. Let's task 1, task 2, task. It's some macro task. So what happens in JavaScript is all the micro tasks will be executed first. If it encounters some macro task like set timeout or set interval, it will skip it. Then it will move to the next task. So what is happening here is JavaScript engine is running the code. It encounters this console log, which is micro. Then it will consider this also micro. Then it comes here. This comes here in the engine. It's not micro. It's macro. Then the engine will skip it to the next task, which is this. So it is also a micro
promise
task.
is a
So it will
micro
execute it.
task.
I mean micro, not macro. Micro. Fine. So micro first, and then macro.
In the last lecture, we learned how an asynchronous JavaScript code gets executed behind the scenes by the JavaScript engine. So let's have a quick recap of what we learned in our last lecture. In the last lecture, we learned that when we have an asynchronous JavaScript code in our program, that asynchronous JavaScript code is handed over to the web API, where it does its job. And the callback function attached to that asynchronous JavaScript code gets registered and it waits in the web API. And once the job of the asynchronous JavaScript code is complete, the registered callback function is either passed over to the callback queue or microtask queue. Okay, so a callback function associated with an asynchronous JavaScript code waits for its execution inside either a callback queue or a microtask queue. Now, for most of the cases, the callback functions associated with an asynchronous JavaScript code, they are passed over to the callback queue, where they wait for their execution. But there are some callback functions, for example, the callback functions associated with the promise, they wait inside the microtask queue for their execution. Okay, the callback functions associated with the promise, they are not handed over to callback queue. They are passed over to microtask queue, where they wait for their execution. Okay, so most of the callback functions associated with an asynchronous code have to wait for the execution in the callback queue. But there are some callback functions, for example, the callback functions associated with the promise, they wait for the execution in the microtask queue. The callback functions in the microtask queue takes priority over the callback function in the callback queue. Okay, that means the callback function in the microtask queue gets executed first. So when the call stack is empty, and let's say in the microtask queue we have 3 callback functions, and in the callback queue we have 4 callback functions. So when the call stack is empty, the event loop will come into picture and it will start doing its job. And what is the job of an event loop? The job of an event loop is to push callback functions from the microtask queue and the callback queue into the call stack for the execution. Now, the event loop will give priority to the callback functions which is sitting in the microtask queue. That means the event loop will push the callback functions sitting in the microtask queue first into the call stack for the execution. So the callback functions sitting in the microtask queue will be executed first. And once all the callback functions sitting in the microtask queue are executed, then only the event loop will start pushing functions from callback queue into the call stack for the execution. So here, the callback functions sitting in the microtask queue gets priority over the callback functions sitting in the callback queue. Let's understand this with an example. So here we have the JavaScript runtime environment, which consists of this call stack, this microtask queue, callback queue, and event loop. Then we have a very simple JavaScript program here. And again, consider this box as browser's developer console, where we will display the output of this program. Now, when we run this program, first of all, we know that a global execution context gets created for the JavaScript program, where all the top level codes gets executed. Now, after the global execution context is created, this console.log statement will be executed. So this console.log is a function, and we know that for each function we call in our program, an execution context gets created for the function. So for this console.log function also, an execution context will be created, and it will get executed, and it will log program starts here in the developer console. And once its execution is complete, the execution context of this console.log statement or this console.log function will pop up from the call stack. After that, we are calling this setTimeout function. Now, if you notice, to this setTimeout function, we have specified a callback function, and for the time interval, we have specified 0. That means as soon as the JavaScript thread hand over this setTimeout function for its execution to the web API, its job will complete immediately, because for the time interval, we have specified 0 milliseconds. Let's understand this. So when this setTimeout function will be called, an execution context for the setTimeout function will be created, and we know that setTimeout function is provided by the web API. That means it runs asynchronously. So JavaScript will hand over this setTimeout function to web API, where it will do its job. And the callback function attached to this setTimeout function will get registered in the web API. Now, since we have specified the time interval as 0 milliseconds, and we know that the job of this setTimeout function is to wait for a given time interval. And since the time interval is 0 milliseconds, the job of this setTimeout function will complete immediately. That means it will be removed from the web API immediately, and the callback function attached to this setTimeout function will be handed over to the callback queue, where it will wait for its execution. Then we have this next statement where we are calling this resolve method on this promise object. Now, when you call a resolve method on a promise object, that promise gets resolved immediately. Okay, so just like setTimeout function, this promise will also be resolved immediately. So when we are calling this, an execution context for this promise to resolve will be created in the call stack, and we know that a promise gets executed asynchronously, so it will be handed over to the web API, where it will start doing its job. And since we are calling this resolve method on this promise will get resolved immediately. Also, this callback function which we are specifying for this method, this callback function will be registered in the web API for this promise. And as I mentioned, since we are calling this resolve method on this promise will get resolved immediately. That means its job will complete as soon as we hand it over to the web API. And the callback function associated with this promise will be handed over to microtask queue, because we have learned the callback functions associated with the promise, they wait for the execution in the microtask queue. Okay, so this callback function which is attached to this promise, it will be handed over to the microtask queue. Then the next statement will be executed. And in the next statement, we are again calling this console.log statement. So an execution context for this console.log function will be created. It will log this message program in here in the developer console, and it will pop up from the execution set. And in this way, the execution of this JavaScript program is complete. Okay, so now there are no more functions to be executed in this JavaScript program. That means now this call stack is empty. And when the call stack is empty, the event loop starts pushing callback functions from microtask queue and callback queue to the call stack for the execution. Now, what do you think? Which callback functions out of these two, these two will be pushed first to this call stack for its execution? Well, we have learned that the callback functions waiting in the microtask queue gets priority over the callback functions waiting in the callback queue. So event loop will first push the callback functions which is waiting in the microtask queue. That means this callback function will be pushed to the call stack for its execution. Now, from within this callback function, we are calling this console.log statement. So an execution context for this console.log function will be created, and it will log this result data in the developer console. So this message. And once its job is complete, it will get pop up from the execution stack. And with this, the job of the callback function is also complete. So it will also get popped up from the execution stack. Okay. So now there is no more callback functions in the microtask queue. So now the event loop will start pushing the callback functions from the callback queue to the call stack for its execution. Now in the callback queue also we have only one callback function. So this event loop will push that callback function in the call stack for its execution. Okay. Now from within this callback function, we are again calling this console.log statement. So an execution context for this console.log function will be created. It will log the message setTimeout call. callback function associated with the. So here it says program starts here, program ends here, then callback function. Reason this callback function is associated with this promise, it takes long time in its execution. In that case, the next callback function associated with this setTimer function, it will have to wait for its execution to complete. So even though here we have specified the time as 0 milliseconds, if the callback function here of this promise is taking long time in its execution, then this callback function will not get executed immediately. It will not get executed after 0 milliseconds. So this 0 callback function will not get executed after for 10 million times. Once its execution is complete, then only the callback function of this setTimer function got executed, and to this time interval, the number of milliseconds which this function took in its execution are also added. So basically, if you specify some time interval for the setTimer function, that does not mean that after that time interval, the callback function associated with the setTimer function will get executed. It might take some more time if the previous callback function is taking long time in its execution. Okay, so this is all from this lecture. If you have any question related to this lecture, then feel free to ask it. Thank you for listening and have a great day.
Value that is unknown now that may become known in the future. In other words, an asynchronous value. Think of it like a ride-hailing app. When you request a ride, the driver makes a promise to pick you up. While you're waiting, the ride is pending. In the future, if all goes according to plan, the driver will resolve to pick you up, then take you somewhere, at which point your ride has been fulfilled. But in some cases, the driver might reject your ride, in which case you'll need to catch one somewhere else. Either way, the original request is now finally settled. As a developer, you might want to create a promise to represent an asynchronous value, but more often than not, you'll be consuming promises to use the result of an asynchronous operation in your code. On the left, we're making promises, on the right, we're using them. When constructed, a promise starts off in a pending state. It's your job to define a callback function called an executor that defines when to resolve or reject the promise. This is where you would kick off your asynchronous work. On the other side, the consumer of the promise has called its then method. It's waiting for the asynchronous value to be fulfilled. When that happens, we'll call this function with the value as its argument. We fulfill the promise by calling resolve, but there's always the possibility of an exception. In that case, we can reject the promise and send the error back down to the consumer, which can use the catch method and an entirely different function for handling exceptions. And if you just want to run some code no matter what, you can use finally to handle both possibilities. All of these methods return promises, which means they can be chained together to handle multiple asynchronous operations in a row. This has been JavaScript Promises in 100 seconds. Thanks for watching, and also make sure to follow my brand new Instagram account for even more content on this topic. I will see you in the next one.
What is the output of this code? Please pause the video and try. Now I'm going to show you the result. And you may wonder, order of the log in that. So you can say I'm in a pretty intelligent way, pretty good task, set timeout. Because set timeout and promises are the different tasks than the main task. Main task will be on the main thread. So this task will be go to the task queue in thread. So it's
I think he's not going to talk about what I'm thinking about.
to task queue. So the event loop or the browser or the node.
I think what I have to do is watch the other video about promises. This guy here, that he explains how it works. I need to watch that more times so I understand. It's probably the best video that answers what I'm looking for, which is the similarity between promise and then set interval as well. I think I have to research as well this microtask thing here. Differences between microtasks and callbacks. Probably mention that in the video as well. And the issue is that then I'm probably not going to be done with this stuff today. I think if I'm not, what I'm probably going to do is finish this by tomorrow morning. And then instead of streaming in the morning, I stream in the afternoon.
And don't forget to hit the bell icon.
The link is going to be down.
I think I'm just gonna mention these things and then tell people to look for themselves. You know, I was debating whether or not to do some closing statement or something like that because it's the last video from Python and JavaScript, teaching Python and JavaScript at the same time. So something like talking about the frameworks and stuff like that, but I think I'm just gonna end without saying anything, any intro thing, something like that. Just gonna finish as soon as I assume there isn't anything else to talk about.
On the other hand, the callback queue, also known as the task queue, is a queue of tasks that are executed after the browser has finished its current task and is ready to update the UI. Tasks in the callback queue are executed in the order they are added, and each task is executed in its own execution context. Examples of tasks in the callback queue include set timeout and set interval.
So the difference is that set interval schedules a callback function, and the then schedules a promise callback. But I don't understand how is it possible that they are different in their interpreter. Mm. And task is added to the callback queue with set timeout or set interval is not executed immediately. Instead, it is scheduled to be executed after the browser has finished its current task and is ready to update the UI. When this occurs, the task is removed from the callback queue and executed on in its own context. So to summarize, the JavaScript compiler does not treat promise callbacks and tasks in the callback queues differently. Runtime environment that determines how and when these callbacks are executed based on the queue they are added to. Oh, so queue is kind of like, is very similar to a list, but it is the implementation that is different, but it's a data structure. So I think I get it that the Node.js or whatever runtime environment has these different queues of tasks, and the classification is based on the syntax, I think, and there is no other special meaning to it besides that. It's just something that people decided that the promise is going to be on the microtask and the callback is going to be somewhere else. But that's the stuff that is not clear still to me, because I'm not really sure if that's the case. So why? Let's see what happens when I ask this. The reason why promise callbacks are added to the microtask queue instead of the callback queue has to do with the way the runtime environment processes asynchronous operations. JavaScript promise is an object that represents the eventual completion or failure of an asynchronous operation. When a promise is resolved, fulfilled, any callbacks that have been registered with the then method of the promise are added to the microtask queue. This is because the runtime environments wants to ensure that the callbacks are executed as soon as possible after the promise is resolved, before the browser has a chance to do any other work. On the other hand, tasks that are added to the callback queue we set a timeout or set interval or not. I guess a better question is were promises handled before existed? I'm gonna try this one and then I'm gonna try another question if this doesn't work. Before promises were introduced, asynchronous operations in JavaScript were typically handled using callback functions. Callback function is a function that is passed as an argument to another function. So I think this response from ChatGPT is probably accurate. I think there's high probability that it is accurate. And that's what I was imagining as well. I just wanted to make sure that the thing that I wasn't sure that promises are analogous or they are built on top of this concept of set interval and set timeout, I think. So just knowing that, I think I can make the rest of the video. I'm just gonna I'm gonna talk about superficially. I'm not gonna, maybe I'll talk about the distinction. I'm probably gonna talk about the distinction between microtasks and callback queues. But I'm not gonna try to explain, I'm just gonna talk about the differences and then I'm gonna point to the videos in the description for more information. And then I'm gonna put this side by side with this one and explain that this was done so that it is easier to write and debug, but it doesn't solve the underlying issue. You can still have problems because there's still no way to find a more efficient way to solve the promises, because if you do it with the promise.all, then there's no way to tell which one's gonna finish first. And if you do it like this, then it's still slow because you have to wait for each one to end until the next one starts executing. And I don't think I remember the guy saying that there is a way to solve this or to make it more efficient. And I already made the videos that briefly explain what a set interval is, and I think the stuff about the events loop that if only executes after everything else is executed. Typically we handled using callback functions. A callback function is a function that is passed as an argument to another function, is executed, blah blah. Here's an example. The example, the set timeout function takes a callback function as an argument and schedules it to be executed after 1 second. While callback functions are still widely used in JavaScript, they have some drawbacks. One problem with using callback functions is that they can lead callback hell or pyramid doom. Let me ask, show me an example of the source code of a promise object in JavaScript. think this is the last one that I'm gonna ask, then I'm gonna stop here. Here's an example of the code for promise. And so this is, it looks different already from the other guy. Yeah, so there's the resolve, reject, and the other function I think is catch, probably. The constructor receives a function, I think, which is gonna be the callback function, which is this executor. Yeah, but here is using promise again. That's the thing that is confusing. I guess it is just a recursive thing where you create a class instead of the class. So it goes recursively until it's fulfilled, I think. That's what's going on. So this is probably wrong because this function doesn't exist. I think I'm gonna stop here. I'm gonna study this a little bit more, and then I'm gonna film the video. Probably gonna talk about superficially, like I said before. Just briefly explain this, show the comparison with the promise, talk about the promise.all and the callback queue and the microtask thing. And that's gonna be it. And then I'm gonna point people to these 3 videos here that I think are the best I found on the topic. So hopefully tomorrow, if I finish this, if I don't finish today, I'm probably gonna finish tomorrow. And then after I finish this, I'm gonna stream and I'm gonna start the blog. I'm probably gonna watch these videos first. I'm debating whether or not to do something on Figma to style the thing, but not really sure if that is necessary because I have a good idea in my mind of how it will look. But I think many people do, especially for big sites, they do the styling thing, so I might do it as well because it probably helps. But I'm gonna watch these videos about blogs here to get ideas of how other people do it and good approaches. And I'm probably gonna follow this guy here because I've seen this video already and I thought it's really good. So I think I'm gonna try to build it with this MDX thing. And then I'm gonna use Theme UI for the CSS, and I think I'm gonna start from scratch. I'm not gonna start from the landing page template that I have. I'm gonna start from scratch, and it's probably gonna be very difficult because it's gonna be a big site. But yeah, so I'm probably gonna come back